Alrighty, guys. Good morning, and welcome back again to Prob Stats today. Happy Monday. For those of you guys that I have not seen since fall break, I have a doctor's appointment today, so I'm going to be out at least for the first half of the day to go get that ironed out. So in the meantime, I've recorded a relatively brief video lesson to kind of get us launched into some of the beginnings of what we're going to be talking about in Unit 3. Unit 3 in particular is going to be addressing how, as statisticians, we describe or quantify the relationships between two different variables at the same time. So something we're eventually going to talk a lot more about is this idea of association between a variable and whether something is causing a response in another to happen, or if there's just a relationship between the two. But in order to get things just kind of introduced, we're going to start really, really small, and we're going to talk categorical variables before we get into the more quantitative side of things. So today's lesson and our day 2 lesson that we're going to tackle on Wednesday as we get back from fall break is really highlighting this idea of two categorical variables and how we might be able to describe the association between those two things as we go along. As far as some of the general announcements, as we get ready for our third unit of the first semester, number one, I'm going to be absent October the 28th to November the 1st. So not this week after fall break, but the entire next week. I'm going to be out on my honeymoon to celebrate my wedding. So I'm getting married. I'm going to be out of the country for about a week. I'm not going to be able to respond to emails, but I'm going to make sure that everything you guys need for both your work and the sub is going to be ready to go before I leave. So my best advice is check Schoology. Make sure to look there for the posted video recorded lessons, the different resources and submission links, everything that you're going to need for that week that I'm out. The other thing to watch out for is that our next quiz for 3.1 is going to be scheduled for Wednesday, October the 23rd, just to check in and see how it's going with these initial basics as we start to build our way up to more of a quantitative side of the equation. In addition, we have for Unit 3 a data project and a student practice portfolio. The Unit 3 SPP we're going to try and aim to have done by about November the 15th. And we're going to shoot for the same thing for the Unit 3 data project, but we'll see how it goes. As far as the Unit 2 data project is concerned, we hopefully have data collected for those of you guys that are using published sources, or even for you guys that are collecting your own, as of that Friday before the break. This week, the emphasis is going to start to collate and do analysis of the data so we can really build out the final product of the project and get it turned in this Friday by October the 25th. The Unit 2 data project is really focusing on how we quantify certain measures of center, spread, location, and shape of data for either a data set that we find that's published somewhere reputable or one that we can either create or gather ourselves. For those of you guys that filled out the Google form asking for a little bit of help on the survey, I'm going to put a link out for that on Schoology and have an announcement for that in each of my classes so that I'm going to help you gather some of those data points, and we'll go from there. All things told, we want to try and get that done by this Friday as we get a little bit further into Unit 3. This is essentially the week at a glance for the first couple of weeks as we come back. We're really going to hit two major lesson topics in the first couple of weeks before we really start diving back into some of the probability work and carrying out from there into our last unit for Unit 4. So our goal today is to discuss and do some analysis on categorical data where we're trying to figure out how to describe a potential relationship. So we're working with graphs and diagrams. We're really just kind of building this intuition for, do we believe there's a relationship at play here? And what could we say about that before we really get into the heavy lifting with more quantitative sites? So what we know so far is that data is either quantitative or categorical. Categorical data, unlike quantitative data, can really only be counted and put into proportions. So for example, if I'm going into an ice cream parlor and I'm saying, hey, for 20 people that are here in the parlor, what's your favorite ice cream? I can really just count that and say what percent of the people I talked to chose mint chocolate chip. And that's really about it. I can't really find an average or a standard deviation for that. I can only count how frequently something happened or how much of the whole that I'm working with. That's the giveaway that we're working with categorical data. It's essentially stuff that's just put into different descriptive groups. When we're working with categorical data, we have a few different data displays we can work with. We can try and represent results for that data set as, say, a pie chart or a bar graph or a segmented bar graph, which is kind of the melding of the two in between. All of these are things that we talked about in the beginning of Unit 2 that you're working with as you're finishing up the Unit 2 data project, so all of this should feel fairly familiar. What we're doing in our unit as we get opened up here is extending that conversation to, instead of say one variable at a time, what happens when all of a sudden we introduce two of them. So the activity that we're on is page 48 in our notes today. Page 48, section 3.1, two categorical variables. This first activity we're going to iron out is called How Are Your Favorite Classes Related? Now, what we're doing here is doing an exploration at first of, say, a student's favorite electives class, and then their favorite core class, and then seeing perhaps if there's a relationship between those two things. And normally this is where I'd kick it over to you guys to put it up to a vote and say, hey, here in Pear Deck, why don't you guys respond to this survey question with your favorite elective class? And then again, hey, in Pear Deck, why don't you respond to your favorite core class? Given that this is a recorded video lesson, I don't have the ability to gather that data from you guys and build from there. So I'm going to use a dummy set of data that I already had recorded from last year, and we're going to work with that data set instead of the data that got collected from you guys. So what I'm going to do is gather up that data in Staplet, and I'm going to show you the initial results that I got from some of my students last year, and then we'll carry on into the rest of the lesson. Okay, so what I've done is I've taken some data that I collected from my students last year, and I've entered it into Staplet's one categorical variable single group calculator. The reason I've done the one group so far is even though I'm going to ask you guys two questions, we're going to leave them separated and then think about some of the potential relationships as our next step. So the first question that I would have asked you guys in Pear Deck is to choose your favorite electives class. This is the data that I got from some of my students when I ran this last year. I had 5 students say that they preferred art, 4 that they preferred music, 17 that they preferred physical education of some kind, 6 that they preferred foreign language, and 3 that they preferred technology. So maybe something with CCIC's like Innovators program, or say something with computer science or STEM. Now, we've seen in the past that we can calculate, say, the frequencies of some of these responses and their relative frequencies, so how much of the total those responses make up, but that's really about it, and that's the hallmark of categorical data. We've also seen that in Staplet, we can change from, say, a bar chart to a segmented bar chart to a pie chart. And definitely looking at the pie chart here, we see that the vast majority of student responses here are going to PE. The second most popular choice was foreign language, and then the next one after that, it looks like was art, then music, and then technology. So most of my students preferred PE as far as their electives classes. Now, the next question that I ask my students is if you had to choose, say, a core class, mathematics or English, which would you prefer? And when I gathered up that data last year, I found that 15 of them said mathematics and 20 of them said English. So if I'm taking a look, say, at the frequencies or the relative frequencies, I can get an idea of the proportions here with a bar chart, but maybe a different data display would help me visually see much quicker how much of the sample of my students preferred, say, English versus math. And I definitely saw a slighter majority preferring English than mathematics. So when we leave these two questions as separate results, we can do analysis of them in the one categorical variable calculator, but it really only tells us what proportion is fitting into each one. When we decide to put these two together here, so if I go to, say, question number 5 on page 48, what we now want to think about is, okay, if we were to have asked those two questions at the same time, what would some of the results be in, say, a two-way table? That's where it's going to start to get a little more interesting. So I'm going to take a moment. I'm going to show you the data that I collected on my students when I asked them the same questions at the same time. And we're going to take a look at whether or not there's a relationship between someone's choice of core class impacted their choice of an electives class. All right. So now when I take that survey question of what's your favorite core class, and I ask at the same time, what's your favorite electives class, and ask students to put themselves in that little two-way table you see in question 5, this is where things get a little bit more interesting. So a student has to put themselves in only one square of the two-way table, which means they have to choose, say, hey, I'm an English person and I really prefer PE as my electives class, versus, say, someone who's in mathematics and they prefer an art class. Now, when I put the data from my last year's results into this two categorical variable calculator on Stapplet, because I'm measuring two variables at the same time, this is where we get into some interesting questions about whether or not someone's core class choice has an impact on what they're going to choose on their electives class. Now, to kind of digest this at first, right, just to take this step by step, I entered everything into the two-way table. You're going to notice there's two new things, explanatory versus response variable. Explanatory is essentially the variable that we suspect is going to impact some kind of response variable. And the response variable is going to change depending on what the value of the explanatory variable is. So for example, if I'm looking at my data set as, say, a side-by-side bar chart, I'm noticing that in mathematics and in English, there's still a very high proportion of students that prefer PE. However, if I take a look at, say, technology, which is in green, the likelihood that someone is a fan of a tech class is twice as high, or a little more than twice as high, if they are a fan of a math class versus an English class. So one thing that I suspected in my data set was that if someone prefers a mathematics course, they might be more inclined to like, say, technology or, say, an art class. If you hover over each of these different bars in the bar chart, you can see the exact proportions of students in the mathematics category and the English category that preferred certain electives. Now, to round out question 5, it's going to ask us about the percent of all students who chose PE, the percent of all students who chose math and art, and the percent of all students who prefer math that chose tech. So this is really coming back to some of the warm-ups we've been doing with probability with the idea of two-way tables. So if I want something and something else, I'm looking very particularly inside the table. Or if I'm looking for the percent of students who prefer math that choose tech, that's kind of like a conditional probability. Now, let's say I want the percent of all students who chose PE. I'm seeing in my two-way table that that's 17 students, but I have data on 35 students total. So that proportion would be 17 out of 35. If I want the percent of all students who chose math and chose art, notice there's only 3 students that fit that category. So it's 3 out of 35, which is about 8.6% when you round to the nearest decimal. If I want the percent of students who prefer math that chose technology, well, if they chose technology as their favorite elective, they can't have chosen anything else. So one of the things they got to be careful about here is if I know they already chose tech, that leaves 2 of those 3 choosing math after they chose technology. So that proportion would be 2/3, which means 66% of students that are interested in a tech class are going to choose math as their favorite course subject. That's like a conditional probability that we've seen in probability. So this is getting kind of interesting, right? The likelihoods of certain outcomes are changing depending on whether they are a math or an English person. Their choice of math or English is beginning to change depending on, say, whether they're a PE, a foreign language, or a music person. So it seems like there's kind of this relationship between the variables where one might be causing something else, but at this stage, we might not know exactly what's going on there. Now, the last thing I want to show you here in our Stapplet is that if you change between some of these different representations of the data, you might glean different information out of this process. If I go to, say, a segmented bar chart, I'm definitely noticing that between the math and the English groups, the people who prefer PE is about the same. And if I look down here at the summary stats, I'm seeing across PE and math, or PE in mathematics and English, those percentages are almost the same. We got 46.7% and 50%. So You can take a look at some of the summary stats to help answer these questions. And in fact, I actually recommend that you do this to help speed up the process of finding some of these answers. So we can gather a lot of data about this. We can see the possible connections, and we're beginning to suspect that there's a relationship at play between some of these different variables. So as you're working through those segments of the notes, what I want you to really bear in mind is, okay, in this question, this survey, right? Who are the individuals and what was the variables that we're tracking? Would you describe those variables as categorical or quantitative? And what we did is we used Staplet to do some analysis on that data as we went further along. Now, that's kind of the intro to the conversation about, okay, how do we look at categorical data to see if there's a connection, and an initial exploration in some of the data displays that we could see. The next activity I want to get into is on page 50. It's called What Will Be the EHS Mascot? Now, this is actually a true story. Back when Eagle Crest was built in 1990, they had to take a vote to choose who their mascot was going to be. At the time, the principal decided to let the students and the teachers vote between three choices: the Cougars, the Raptors, and the Wolves. Now, they took a random sample of students and teachers, which means they got a roster of everybody in the whole building who was a teacher or a student, and they randomly selected people out of that roster to try and keep it fair and representative. Now, when they collected that sample, they got these results as far as the proportions of those groups voting for either the Cougars, the Raptors, or the Wolves. So what I want you to think about here is, given that data set, how can you use, say, Staplet to build two bar graphs to the right to display those results, and then say, okay, what appears to have been the most popular choice? Now, if you're trying to do that in Staplet, we're going to stay in the two categorical variable calculators. We're going to reset everything to get kind of a blank slate here, and we're going to build this out slowly all together. So I've got, say, an explanatory and a response variable. At this stage of the conversation, it's not terribly important which one's which. I'll say maybe that the explanatory variable is staff versus student. I just have two categories there, right? I'm either a teacher or I'm a student. In my response variable, I might say mascot. And in that particular setup, when I click this plus button to add a row, I've got three choices. They could have been Cougars, they could have been Raptors, or they could have been Wolves. Now, one of the difficulties that we see in our two-way table is that we have percentages, right? Which means we have to think about what that percent is saying for some number of people out of the whole group, right? So let's assume for the moment that there were 100 teachers and 100 students that got selected, just for the sake of the argument, to make this a little easier to think about. If 80% of teachers voted for Cougars, then that would mean 80% of 100 voted for that. So that would be 80 teachers voting for that response. And then if I've got 10% and 10% for teachers and Raptors and Wolves respectively, that would mean there was 10 votes and 10 votes there. So just to keep it simple, I'm assuming that there were 100 teachers and 100 students in the sample. We're actually going to see later in this activity that that's not quite the case. But for the moment, we're going to operate under this assumption. Going back to students, we see that 30% of students voted for Cougars. So I'll write a 30 there perhaps. For Raptors, I see 60%. And then for Wolves, I see the final 10%. So I've got 100% of the teachers and 100% of the students accounted for. When I hit begin analysis, what we're focusing on at first here is the side-by-side bar chart and the segmented bar chart. So if I look at, say, the side-by-side bar chart, one of the things that immediately I recognize here is that the vast majority of teachers voted for the school to be represented by Cougars. A smaller percentage of the students, about 30% of students, voted for that, but visually, it kind of looks like Cougars won the vote. About 80% of staff and about 30% of students voted for the Cougars. So if there's 100 in each group, then that would lead me to believe that the most votes was for the Cougars, and we should have been the Eagle Crest High School Cougars, not the Raptors. Now, if I go from, say, relative frequency to frequency, we're going to see essentially the same result. It's just a whole number because we assume there's 100 in each category. So that change is not as useful. If I go to, say, a segmented bar chart, notice that I have a bar for the teachers and a bar for the students. And then I'm breaking this down by color coding the percent of the whole bar that's represented by each of these three votes for either Wolves, Raptors, or Cougars. So visually, it strikes me, especially in a segmented bar chart, that Cougars was the largest sized group. So visually, it would lead me to believe that we shouldn't have been the Raptors, we should have been the Cougars. So as we get into part three and part four there, we might be noticing something that's kind of weird here. We're the Eagle Crest Raptors, but based off of this data, we should have been the Cougars. We should have been something else. So the question in your mind, hopefully, is what gives? What's going on here? Now, if you take a look at part four, notice that they did not necessarily talk to 100 teachers and 100 students. They actually talked to 100 teachers and 500 students. So in total, the sample size was not 200 like we assumed at first. It was 600 people that they included in the vote. So that means we have to think about how to change our two-way table to accurately reflect the effect of the sample size in this. Now, thankfully, the teachers column is going to remain mostly unchanged. There were 100 teachers, and 80% of 100 is still 80. 10% of 100 is 10 and 10. It's in the student category that this gets a little different. If I had 500 students and 30% of that voted for, say, the Cougars, then 30% of 100 would have been 30 students. But I'm not dealing with 100, I'm dealing with 500, which is 5 times as many. So if I take 30 and I multiply it by 5, I'm going to get 150 students voted to be the Cougars. Now, I'm going to do something very similar here for the Raptors. 60% of the students voted for Raptors, and if there were only 100 students, that would mean there were 60 votes for the Raptors. But there were 5 times as many votes as what we initially assumed. So if I take 60 and I multiply it by 5, I'm going to get a result of 300 student votes for the Raptors. And then finally for the Wolves, 10% of 500 is not 10 votes, it's actually 50 votes. So I needed to account for the size of the survey in this. Our initial assumption was incorrect because it wasn't a 50-50 split between students and staff. It was actually a 5-to-1 ratio. For every teacher vote there were 5 students voting to counteract it. Now, if I take a look at some of the results now in this, you're going to notice that the Raptors are having a much better time in, say, a segmented bar chart. We see a much more representative representation here. However, if you take a look at, say, the relative frequencies, you may notice that the results don't seem to be terrifically different. So the last visual display that we might take a look at is something called a mosaic plot. So here in Statplet, in the two categorical variable calculator, hopefully you've been following along and putting this data in the table. If you switch to a mosaic plot, what I want you to notice is that there's something new to account for in the display. On the top of the chart, you've got these increments of 20%. So 0 to 20, 20 to 40, 40 to 60, so on and so forth. If you take a look at this bar that's on this kind of left-hand edge, the teacher group is that one column on the left that's much smaller than the group on the right. The group on the right accounts for more than 80% of the votes. In fact, if there were 600 votes and 500 of them belong to students, then that means only about 16.7% were teachers, and a little over 83% of the votes were cast by students. So students had much more of a say in the Eagle Crest mascot vote than teachers. And what this mosaic plot is doing is it's trying to account for, with this square area model, the proportion of votes that were teachers versus students, and then the categories on the inside. So if you're looking at a segmented or a side-by-side bar chart, it might sometimes be difficult to see how the sample size gets represented in that illustration. However, in a mosaic plot where everything is represented as areas, now we're definitely seeing why we're the Eagle Crest Raptors. If I hover over this group for students that supported the Raptors, It's 60% of the students, but that's 50% of the entire vote. 50% of the entire vote were students saying Raptors, and then 1.7% of the entire vote were Raptors, but also teachers. So that's why we're the Eagle Crest Raptors instead of the Eagle Crest Cougars. Previously, under the assumption that it was a 50-50 split between students and teachers, we wouldn't have been the Raptors. But once we correct that and account for the true sample size, now we see the difference. So really bringing this back together, that's the final thing in part 5. A mosaic plot accounts for the size of the sample in addition to the relative frequencies and the different categories that were at play in the problem. So as we kind of close things out, the things that I want you to write down in this vocab part of the notes for 52 is just some of the terminology around the basics. A two-way table is something that we've been familiar with in a variety of different contexts, but in statistics, we use a two-way table to display frequencies or relative frequencies for two categorical variables at the same time. A two-way table is how we enter data into Staplet and then use it to build things like side-by-side bar charts or segmented bar charts or mosaic plots. These different plots are all constructed in Staplet from an initial set of data that needs to be entered either as a true frequency, like how we corrected the votes for the two-way table, or just a relative frequency, percentages of a total. Now, the other thing that we've been talking about is the association between variables. If we take a look at our data set, it seems that if you were a teacher, you were much more likely to vote for the Cougars than you were as a student. If you were a student, you were much more likely to vote for the Eagle Crest Raptors. So it appears that there is a relationship between your status as a student or a teacher and how you cast your vote. Now, when we talk about these possible relationships, the question we want to ask ourselves in our minds is one causing the other to happen? The thing that we suspect is causing the result to occur is what we call the explanatory variable. It explains why the result happened in the other case. The thing that's changing as a response to the explanatory is called the response variable. So we might believe in our data set that whether you're a teacher or a student is impacting your vote. That's the explanatory. And the response is how you voted. Sometimes it might be the other way around, though. And that's where we have this note that says correlation does not imply causation. This is essentially the really important idea that we might detect there is a relationship, but it's actually really difficult to prove which way it's going. It's hard to say whether being a teacher or a student caused the change in the vote, or if the vote was perhaps causing a change in whether you're a student or a teacher. Now, in our particular example, one of those statements definitely seems like more common sense than the other. But oftentimes in statistical work, especially when we switch to quantitative variables, it's very difficult to prove which one is causing the change in the other to occur. So as we wrap things up, as we get into page 53 and 54 of the notes, I want you and your group mates to try those couple of examples as we get ready to switch gears and get some time on a project. For today, I really just wanted to introduce this conversation and make sure that we tackled this initial exploration in our notes. There's a couple more examples here where you can use Staplet to help you find answers to some of these questions, where we're doing some analysis and some interpretation of these charts. When I come back on Wednesday, we'll do maybe one or both of these as a warm-up just to make sure everyone's on the same page. But I want you to try both of these with your group mates. And then once you're done with them, I want you to switch gears and continue working through the analysis for the Unit 2 data project. The Unit 2 data project is going to come due this Friday. So I'm going to make sure that you have a little bit of time today and some time Wednesday and Friday to put the final touches on it. But in the meantime, I should be back on Wednesday. I've got my doctor's appointment today, which should be going pretty smoothly. But otherwise, I will see you guys again on Wednesday. I hope you guys had a fantastic fall break, and I look forward to seeing you soon.